let us consider a light ray is traveling from air to glass. This way, we'll consider a ray of light. Say P, and here the point is O. So O is the point of incidence on the boundary of air and glass. Okay. Now, instead of going straight like this, it will bend and travel. Okay. Say Q. Now, what's happening is PO is the incident ray, OQ is, we'll call it as refracted ray. Okay. O is the point of incidence. Now, if I draw a normal, NO N dash is the normal to the boundary between air and glass. Okay. So, the angle between PO and ON, this angle here, this we will call it as angle of incidence, whereas the angle between N dash OQ here, this angle we will call it as angle of refraction. Unlike in the reflection, we have here angle of refraction. Okay. Now, when the light ray is going from rarer medium to denser medium, it is bending towards the normal, which implies that the angle of refraction is less than the angle of incidence. Now, instead of going straight like this along this path, it is bending and traveling. So, we can say the light ray is deviating from its path. By how much? So, to know that, we will measure this angle, the angle between the direction of the original incident ray and the refracted ray. Okay. So, we will call this as angle of deviation denoted by D. Right. Now, let us assume that the velocity of light in this medium here is C. C is the velocity of light in air, and let us say Vg is the velocity of light in glass. Okay. So, first law of refraction tells that whenever a light ray is traveling from a rarer medium to a denser medium, it bends towards the normal. Unlike this, if we take the other way around, that whenever a light ray is traveling from, say, glass into air, there is another situation where now P and O, here this is the incident ray and it is traveling in glass. O is the point of incidence. So, here I draw a normal NO N dash. Now, instead of going straight like this, it will bend and travel. Okay. So, in this case, because it is going from a denser medium to a rarer medium, it will bend away from the normal. Let us say this is Q. OQ is the refracted ray, PO is the incident ray. The angle between the incident ray and the normal at the point of incidence is the angle of incidence. Similarly, the angle between the refracted ray and the normal at the point of incidence, this angle, here it is angle of refraction. Now, if at all it is going straight, it will go along this path, but it is getting deviated from the original path. So, this angle here is the angle of deviation. Now, whenever a light ray is traveling from denser medium to a rarer medium, it is bending away from the normal, and in the other ways where it is traveling from a rarer medium to a denser medium, it is bending towards the normal. These two are the laws of refraction. And the other thing is like the incident ray, the refracted ray and the normal at the point of incidence all will lie in the same plane. Now, every time it is not possible for us to find out how much it bends whenever a light ray is traveling from one medium to the other medium. It is not possible for us to measure the speeds. Okay. So, the reason behind bending is very clear. It is because of the difference in the speed. The speed of light in a denser medium is less compared to that in a rarer medium. Okay. In air or vacuum, you will take the speed of light as c is equal to 3 into 10 power 8 meters per second. But whereas in water or glass, in any other medium, it is lesser. Now, one more point what we need to consider is, okay, here when I am having this angle of incidence, I am having a refraction angle less than that of the incidence. Even if I increase the angle of incidence in this case where the light is going from rarer medium to denser medium, always it is possible that the angle of refraction is less than the angle of incidence.